All right, welcome everyone. My name is Paul Meyer. I'm the editor of Acres USA magazine, and glad to have you at this webinar here today with Dan Kittredge from the Bionutrient Food Association. And Dan is going to be a speaker at our 50th annual Acres USA conference and trade show. It's December 1 through 4 in Madison, Wisconsin, and we'll drop the address for that into the chat. We are going to be recording, or we are recording this webinar, and it'll be on YouTube, and I think it'll come out as a podcast as well. And if you have questions to ask, please throw them into the Q&A box that's down at the bottom of your Zoom screen. And with that, I'm going to give it over to Dan, and as he begins to introduce himself, I'm going to pull up his slides so that he can share that with you. So here you go, Dan.
All right. Thanks, Paul. Really happy to be here. Um, really honored to be speaking at the 50th annual Acres USA conference. I mean, as I was just saying before we started here, it's the place where I learned everything. I mean, I learned a lot growing up on the land, but there's a bunch more that I learned from the circle of elders, and that's Acres is where it was. So this term nutrient density that we're talking about here today, as I was just saying, was coined at Acres as part of a conversation with the Acres elders about how do we talk about this thing you guys call bricks and its implications. So this is the farm I grew up on in central Massachusetts. It was a homestead, back to land, milk cow, wood stove, root cellar. My parents, helped found NOFA, Massachusetts. We're active in the organic movement for 35 years. Helped write for some of the first organic standards. This is the place I grew up in. But let's move on. I founded the Bionutrient Food Association in 2010 as a nonprofit with a mission to increase quality in the food supply. And in that, we're talking about flavor and aroma and human health, ecosystem function, not volume and aesthetic, like a lot of food is sort of quality is defined currently. Next slide. Yeah, so we were founded in 2010. We did a lot of work. Basically, I took the practices I learned at Acres and applied them myself and saw the amazing results. And basically, because I had enough time as a farmer to do things besides farming, I started talking and started giving courses and workshops, and started a conference. And here you see some of the speakers we've had at our conference. I really thought, speaking to Acres, about Charles Walters. He was such a brilliant, brilliant man. And I saw as he was getting old and things succeeded through the lineage of Acres, that the insight that was so multi-dimensional, if I can say that he was bringing forth, wasn't being held there. So I feel like we've successfully brought that forth in the history of the Soil and Nutrition Conference that the BFA has been holding for the last 14 years. But yeah, it all stems from that insight. And here's some of the speakers we've had in the past. What as part of what we did, we saw that if people worked with biological systems, again, from Acres, biological ag, um, cost of production went down, soil health improved, pest and disease resistance improved, flavor, aroma, shelf life improved, nutrition improved. So if you go to the next slide, Paul, we basically thought it would be great to start bringing forth the science around this, because that was one of the basic critiques of bricks, was we didn't have solid science around bricks to show that it did what everybody who was part of the community knew. So this was 2017. We had this idea that if you could build a meter that people could use to test food non-invasively with a flash of light, as opposed to a refractometer, basically exactly the refractometer, except with a flash of light and with numbers that scientists would approve. If we could give people that capacity, we could change the world. if it was true that nutrient variation was dramatic, if it was true that it connected to soil health and all these things, which we farmers were seeing, but wasn't well supported in the literature. So next slide. Yeah, we did a bunch of research for a number of years. This is just the data from 2020. You can see each of one of those green dots is a farm that was sending in their crops in triplicate and the soil from underneath them in triplicate at 0 to 10 and 10 to 20 centimeters, answering a bunch of management data questions. We did this in 2018, 2019, 2020, 2021. I think 10,000 crop samples, hundreds of farms, multiple continents, as you can see, dozens of crops, numerous nutrients, to begin to establish the data framework around this deeper question about nutrient variation and things like that. Just next slide. Next couple slides are basically about data from carrots, but you just saw previously that we had data from a bunch of different types of crops, and these graphs are very similar to what we found from everything else. These two are sulfur and phosphorus. These are two elements. You can see in the sulfur at the bottom left, 8.41, in the bottom right, 33.19. That's a 4-to-1 variation in levels of sulfur. You can see the peak there is the red, orange, yellow, light green, dark green. That's 0 to 20, 20 to 40, 40 to 60. The peak is about 23%. Like the vast majority of the samples are below the 50th percentile. Most nutrients, I mean, most crops have relatively low levels of nutrients, at least in sulfur. Phosphorus, same thing. Peak in the 27th percentile. A bunch of samples, not many that are at the high level. Next slide. Antioxidants, these are sort of very powerful health-giving attributes. 4.92, 195, that's a 40-to-1 variation, peak of the curve in the 13th percentile. Variation is dramatic. Most of what's available is relatively low. Polyphenols, 2.34, 49.75. That's a 20-to-1 variation. It's the nutrients that our bodies have evolved to discern, things we call flavor and aroma. Peak of the curve in the 7th percentile. Dramatic variation. But yeah, most of what's available is not good. Next slide. So that was basically what we, does variation exist? Is it significant? Yes. Now these next few slides are talking about what caused it. On the left, we look at different varieties. Again, carrots, Napoli, Bolero, Nantes, Mokum. Some people say genetics matter. If you look at these slides, you see no one variety seems to be dramatically better than another. There seems to be something else going on that's causing it. On the right-hand side, you look at soil type and climate zone. What causes nutrient variation? Northwest, east, north, central, southwest, central, northwest. This is the US. Lots of people are doing a relatively bad job in most places. Almost no one's doing a good job anywhere. It's not about where you live or what your soil type is or climate zone. It's not about what variety you planted. Some people are doing a good job, but most are not. Next slide. Here we look on the left at where the source of the crop was. Some people think if you go to the farmer's market or you grow it in your garden, it's better. Here we have farm, store, garden, farmer's market. There's almost no dark greens. There's a bunch in the red and the orange and the yellow. Like where you buy your food doesn't seem to be the point that differentiates. On the right, we have certified organic, cover crops, no-till, tillage, organic. Reference none is the grocery store, not organic. Things like I'm certified organic, we do no-till, we're, we use cover crops. This doesn't seem to be what correlates with nutrient levels in food. What we found this, preliminary work was that it seems to be nutrient variation is dramatic. Certification labels, genetics, soil type, those kinds of things don't correlate. What we found was that levels of life in the soil did seem to correlate with the um, quality of the food that's producible. Next slide. Again, part of our idea here is that we can build instruments that people can use to test. This is, the next level of the refractometer. This bionutrient meter that we released in 2021. We published a paper in Nature Science Communications in 2022 that showed that you can build a handheld flash to light nutrient meter that can give you real readings on food. So yes, is it possible to create this reality going forward for how to organize the market and support consumers and support farmers? Yes, that was the grand vision. We basically identified at this point in time that this was a very plausible scenario. And so, next slide. We move forward to the deeper question, which is what is quality? The Brix reading of, poor, average, good, excellent, laid out by Reams. Most of us follow, but we can't find the science behind that. So the real idea is, okay, so it's great you can build a meter now, and that it could work. It could be you as an average person could afford to hold, and it's possible to have a thing in your hand that could test nutrients. Now the question is, which nutrients are we testing, and how do we say what good and bad are? So we started this project in 2021 with beef and used that as our first crop to begin to test to see can we build a standard that a meter could be calibrated to. This was the thesis, basically, was that if cows ate what cows have evolved to eat for millions of years, the meat we get from them would be better than if cows ate, a lot of grain, basically. Next slide. So here we have the sort of experimental design. We worked with Stefan van Vliet as our primary investigator at Utah State. Developed this protocol. We looked at the nutrients in the meat, the microbes in the manure, the forage, the soil, how the animals were fed and managed, and what their life cycle looked like, as well as human health trials, to begin to build a bunch of data points. And the idea was that nature works in patterns, and if we can use science to collect enough sort of data points, we can look for the patterns that we think correlate between soil health and animal health and ecosystem function, farm viability, flavor, aroma, and human health. Next slide. We sampled across North America very well. Some Europe, some South America. There's a few more in Australia, New Sea, but we were trying to really, as much as possible, get a global representation. Obviously not perfect, but at least moving forward from just North America and Europe. Next slide. Omega-3, omega-6 is one of the compounds ratios that we've identified as seems to be a defining factor in this whole process. And you can see that there is a dramatic variation between cows that are finished on grass and cows that are finished on grain, although there is, ups and downs between them. Next slide. In very short, it looks like the diversity of the ecosystem that the animals have access to is a very good predictor of the nutritional quality in meat. This is a slide that's a few months old now. Our final definition of nutrient density in beef is hopefully we publish in about 6 months. And that'll be the first ever definition of nutrient density in any crop. Again, as part of this whole 1 to 100 definition process that's based on nutrients and numbers, not sort of a series of practices. So that's the end of my first slideshow, I think. Are there any more slides there, Paul? Oh, yeah. We are we are a nonprofit, and we take donations. I'm not sure where that picture came from. It's not part of my slideshow. Okay. Yeah. So what I'm very excited to talk about today is where we're at now going forward, and that is that we've been engaging as the BFA Bionutrient Food Association and the Bionutrient Institute, our scientific wing, in this deep and long strategy of work to build a collective understanding and agreement and engagement around this term nutrient density, this concept. Um, and so for the past number of months, I've been traveling the world. I'm not sure, Paul, do you mind going to the Bionutrient Institute.org page and pulling up?
Yeah, give me a second.
Yeah.
Keep talking.
Yeah, well, we're working on this treaty. And the idea is that who's this? You gotta tell us who these people
Oh,
are.
those are my daughters.
Those are your daughters. They're, yeah, beautiful.
Yeah,
I was
yeah,
like,
thanks.
I don't know. This is
Yeah, I know. Who
not
are
my
these random
slide.
people? Right. Say it again. Bionutrient.
Institute.org.
It'll come.
Okay. Yeah. So the idea basically here is that if we could come together around a common definition of quality in food and have it be based in science and understand the connections between how plants and animals are raised and management practices and fertility programs and genetics and all these kinds of things and health, farm viability and nutrient levels and pest and disease resistance and markets and meters, we could actually develop a real systemic solution to empower people who want to work more well with biological principles and overall well-being. So as part of that process, we've basically developed what we're calling a treaty. And I think of a treaty like there's all kinds of treaties, like the treaty on you know, um, um, fishing in the international waters, treaty on chemical weapons. There's all kinds of treaties that various groups come together around. Think about countries all coming together. Like, how can we figure out how planes fly across countries or where boats can go or whatever? Um, so this is a concept of a treaty, like all of us involved in agriculture, in food, in the soil, in the environment, and human health. Can we build together a plan that is one that uses science and integrates all the different perspectives into a sort of a common deeper understanding? So I think all I wanted people to see here is it. I'm sorry it took so long to get to this URL, but this is a website where this is happening in real time. We're about to walk through the treaty here in a moment with the slides, but thank you, Paul, for just scrolling down. Um, um, keep going, but um, yeah, we've been having a series of events, and part of the idea is, here it is. Yes, keep going just a bit more. Global dates and recordings. Yeah, this you can just run through these next couple lines slowly, but um, we are going around the planet and presenting this concept of like a open science framework to define this. We've just completed Australia and Europe. Um, Scroll down a bit, Paul, if you would. Yeah. Um, Keep going. Yeah, we're about to do South America and then Africa. We're here in North America right now. We're hoping to have a final version of this treaty presented at a conference in Europe at the end of this month. Next line there. No, keep going through. You got to go South America and then Africa. Yeah. These are all dates upcoming in the next 3 weeks. Then we launch it in France. Um, and once the treaty is complete, then we're looking for people to sign it. So we negotiate the treaty, we sign the treaty, and we're looking for, hundreds of people around the planet to do so and say, okay, this, if they agree with it, this makes sense. And then we proceed forward to the funding and the actual implementation. So I just wanted to show this slide here, or to see, like, we're actually engaging a whole global community of people in this conversation. I was just talking to some people from England yesterday, and they were all excited about the politics in England and the personalities in England, and people in South America today, and they're all very interested in who the players are in South America. And whenever you talk to an American, they only ever think about America. If you go to talk to a Californian, they're pretty sure California is the only reality. But we're on a planet here. We're all in this together. That's part of what we're trying to bring together, is this conversation is, can we find a common definition together? But yeah, can we go to the last slideshow there, Paul? Okay, great. Well, this is the treaty itself. Again, it's a draft version where every time we have an event, um, we basically get people to offer comments and critiques and suggestions, and that's part of the drafting process. Um, is that we're literally taking people's comments now to improve it. So, next slide. Recognizing the accelerating global discourse around nutrient density as a pivotal concept in food system transformation, acknowledging the absence of a widely accepted empirical framework to define and measure nutrient density across crops and livestock types, affirming the collective responsibility to create food systems that restore ecosystem function, support vibrant human health, and reflect the wisdom of natural processes, establishing the process. This process, we, the undersigned, aim to define nutrient density in food to advance its global definition, measurement, and integration into food systems. Yeah, I can read these slides as we proceed forward, or people can maybe just take a moment to read them. Um, that might be nice if you want to just actually walk through this and put it up, and maybe spend a minute on each page, and just I'll turn my camera off and people can spend the next 6 or 8 minutes reading each of these. Can you do that, Paul?
Yeah, sounds good.
All right, great. Just take a minute. Great. That was a that was a quick walkthrough of the pages as they exist. But effectively what we're proposing is that um there was 20 different crops. We want to define nutrient density from a 1 to 100 um scale in 20 crops over the next, we're basically aiming for the end of 2028. I think we have third quarter projected right now as a timeline. We're saying it would be about $25 million, million and a quarter per crop. There's a step-by-step process. We do experimental design first, then we do a sample collection, then we do assessment, then et cetera, et cetera. Yeah, we're basically following the model that we used in the beef project. And for anybody who's talked to Stefan Van Vliet recently, he's presenting for people who want to send in beef samples a score where they can get a result, on their beef, and that's based on exactly what we've done here. So the idea is, if we can come together as a you know the people of the planet around this important question, we can agree on a process. We can, those of us who want to put our names on it and say we publicly support this process, and then we can go to allies that want to see it succeed and say, look, we need $5 million in phase one for the planet. Like, you got 10 grand or 20 grand or 50 grand or $5 a month. And agree on a process, raise the funds, do the science, and publish it. And we think by 2028 we can have definitions for nutrient density in 20 crops published, official, like foundational baseline definition existing. From that point in time, you'll be able to build meters that can test nutrient density. This has been one of the biggest questions I've faced for years. Dan, when's that meter gonna be ready? The meter that does what? The meter that tests nutrient density. You can't have a meter that tests nutrient density until you've defined it. This has been one of the central struggles we've had, is like, there's a concept, there's a vision, there's an understanding that we all implicitly have, but we don't actually have the science yet in a formal way to do the thing, which would be to calibrate a meter to be able to measure it. And so that's what this treaty is about, is bringing together a global coalition to accomplish that. And we propose ourselves at the Bionutrient Institute as the stewards of this process. That's part of what the treaty says. And if people want to propose a different organization as a steward, great, and sign that document. Okay, I'm happy to back off if anybody else wants to take it over. But yeah, we're proposing to coordinate the process, but we're proposing that it shouldn't be just us. It shouldn't just be the Bionutrient Institute. It should be a bunch of people from on the planet who get this and all want to see it succeed. So the website that Paul just put up there, bionutrientinstitute.org, is where it's all being operated through. The first slide that I think he showed was like a series of steps, how you can engage, read the document, offer critiques, sign along, tell your friends, make a donation. Yeah, so that's basically, I think, the presentation. I was given 30 minutes, and here we are at 2:29. So really
Yeah.
excited to engage Q&A and conversation.
Yeah, I think that's great. Thanks, Dan. Yeah, we have some questions, and if you have more questions, please type them into the Q&A box. Um, First one, how will the program develop a singular nutrient score for a specific food product? When there are multiple nutrients, different health benefits for in each crop, are scores weighted, or are scores just provided for all available valuable nutrients for each crop? How did that, maybe you can talk about how you did do that with beef, or didn't do it, or
Yeah,
for whatever reason.
yeah. The point is that beef is entirely different than potatoes, or which are cucumbers and blueberries. Every crop is going to be unique. Every crop needs its whole science project done. We have to take in samples of the cucumber and the soil it was raised in, and all the metadata for how it was managed, and the human health trials of people eating the different cucumbers and the microbiome assays. And then we give that data to the scientists, and they say, based on everything we understand, these are the compounds in cucumbers that we think you should be measuring, and these are the levels and ratios that correlate with 10, 20, 40, 80 out of 100. So yeah, quickly, that's the process. We have to look at all these different things. Um, it's a bunch of lab work. It's a bunch of just basically running stuff through labs and getting numbers, and then doing statistics and building algorithms, and going through the scientific method of peer-reviewed published papers and journals. And I don't think I said it before, but um, we hope that this is just the beginning. We're almost entirely positive that what we come up with in this first phase is not going to be the final answer, but at least it's a stake in the ground and saying, um, here's a way to go forward potentially. And if we're successful, I think national governments and things will start to um, fund this in much greater degree, and we'll have better calibrations and better meters and all that kind of stuff. But somebody's got to start somewhere.
Yeah, yeah, no, that's great. And I think maybe the question was getting at also, do you envision this? I know you don't have the data yet, but do you envision it being, for wheat, say, is there going to be one number, or are there going to be five numbers, or 10, or
For
100?
wheat, there would be a 1 to 100 scale. For potatoes is a 1 to 100 scale. For beef is a 1 to 100 scale. You can attest this wheat berry, this potato, this steak, and get a number 23 out of 100. And they're all going
And
to be different. Yeah.
but that's a composite of a number of different
Yes.
attributes. Got it.
All
Great.
come from a series of meta factors. Yes.
Got it.
We
Okay,
hope
good.
will can be continuing to evolve. And what we start with as a baseline definition, we hope in 5 years has been improved upon.
Right.
Yeah.
And then producers are able to put that on their label, right? And consumers are able to see.
Anybody with a meter anywhere in the supply chain can test. So you can put on a label if you want, but it looks like in the end game of this by 2030, there will be parts of the camera in your phone that can do this. So it'll be an app. So
Got it. Yeah,
yeah, I mean, label or market or not. I mean, labeling or certifications or not. The point is people can test for themselves.
right. Great. Dina's asking, will you measure pesticide and herbicide residue as well?
Um, Depending on how much money we have and what gets prioritized through the experimental design process, we might look at pesticides and herbicides. Um, this is called original research, which means we don't know what the answers are going to be. And if there's certain toxins that look like they're key things to be having assessed, great. Um, the point is relative quality. And there's nutrients and anti-nutrients. So um, certainly the implications of that will all be integrated, but original research is a thing in science. This is like you go in knowing you don't know the answer. So that's how we're hoping to engage this process, is like the scientific method, like really use it honorably if we can.
Yeah, great. Um, and I think, yeah, Stephen is asking, will we have access to how the combined score of 1 to 100 is determined? I assume the answer is yes.
Everything's open source.
Yeah,
It only exists after it gets published in a peer-reviewed journal.
great,
So it's the whole idea of science is like, yes, everybody can look at it and critique it and publish an alternate paper and disagree with it. And yeah,
great.
yeah.
Dina is asking, will you measure produce, greens or tomatoes from Dutch indoor intensive greenhouses and grown hydroponically? I assume you're going to be testing all kinds of different tomatoes, field grown, hydroponic, etc.
All 6 continents. If you actually read the treaty, it's coming from all 6 continents and all major growing areas and all environmental conditions. And this is a global treaty for potatoes, for rice, for milk. And by doing global, that means you actually literally take samples in from the entire planet. And all environmental conditions and management practices. We really look at that as part of the experimental design and make sure we're capturing like the important segments of the production process. Yeah.
Mhm. Yeah, and people are asking if you have any specifics yet about aeroponic or hydroponic versus field grown.
Um, I mean, the basic point is that um, field grown can be exquisite or atrocious, and aeroponic can be, you know, a massive variation as well. Um, it's like if you're, I don't know, if you're Christian or if you're Buddhist, like aeroponic or soil grown, like, you know, these things are done in a full continuum. Yeah.
Got it. Maybe if we could get your contact info put out again. Someone's asking if they could collaborate with you to do some testing on beef in Costa Rica. So,
Yeah. Well, I mean, bionutrientinstitute.org is where this all is being housed. And if you literally just go there and check the boxes and say, I want to engage or I want to help out or I got more questions, that's the way to do it. At bionutrient.org, we also have a series of ways people can send in samples to labs and look at different nutrients and crops and things like that. So bionutrient.org and bionutrientinstitute.org. If you just go to those websites and read the header bars, you'll find the ways to engage.
great. Anna says, when I work with nutrition analysis done by laboratories, the uncertainty is sometimes 25%. How precise do you think your nutrition density analysis will be?
Well, I mean, these are the actual serious questions that real scientists ask. Like, how do you get rid of experimental error? What's your confidence interval? Um, a key part of this process of defining the density is that we have to have the samples running through the same lab. Because if you have samples running through different labs, you get varied readings. So we'll definitely be doing that, and all the metadata, everything's going to be collected, all the frequency spikes and which instrument was used and everything else will be open and published. Um, it's one thing to develop a standard, it's another thing to build a meter that can test. So that's not what we're worried about right now. What we're worried about is developing a standard for a definition of what nutrient density is, and then people who build instruments, you know, will be able to say, the sensor in your iPhone seems to work pretty well, but the one in your Pixel does not. And the Galaxy's, 85%. Our job is to say this meter you can trust, that meter you can't trust. After we say this is the standard that we think we should be calibrating meters to.
Yeah, great. This
Yeah.
is more a comment, but you could comment on the comment. It'd be nice to think government should be involved, but I'm not holding my breath. I believe we need to fund this and see it through ourselves. Um,
How does it work? Um, if not us, who? If not now, when? Um, a small group of committed citizens can change the world. In fact, it's the only thing that ever has. Um, yeah, we are still the people, and I would say that our dollars, euros, yen, rupees, renminbi, are the things that actually have significant effect in the world. Our hope is that if we can establish a foundational definition of nutrient density, that you know those larger systems and structures of culture can take it to the next level. But we're always going to say, based on who we are, this is the best science we understand, and have that be a lens of discernment. But yeah, any one of these crops should be looked at, $150 million level instead of a $1.5 million level. And so that's probably only ever going to happen with governments. And if we, the people, can come together and inspire the governments to do, good things, then good on us. We're leaving the world better for our children, which is what we should be doing.
right. Um, Excuse me, someone's asking, are nutrient levels higher when soils mimic those in aged forests versus supplemented with organic fertilizers?
I guess this is all part of the research. Um, it sure looks like uh, the function of the microbiome and diversity microbiome is a very, very powerful thing. Um, yeah, fertilizer in general, I'm not in favor of. If you're looking at the technical scientific definition of the term, which is a soluble nutrient, organic or inorganic, fertilizer is not what we're looking for. We're looking for um, it's the microbiome doing the work.
Good. Um, Here's more of a practical question. Do you have examples of wholesale contracts or sales where nutrient density is being rewarded?
I was just in France, and if you look on that, schedule thing, there was a group we met with in France. They're called Blue Blancoeur. They have a certification label which is based on omega 3/6 ratio, which is what I just showed you with the beef. They've got a 2.5 billion euros a year in sales under their label. So I guess that would count as one, maybe. Yeah,
Yeah. No, that's great.
yeah.
Um, Someone's asking, have you had personal experience with achieving bricks of 14 or higher, and how did you achieve it? Um, yeah,
Yes. Through an integrated process of working with nature. Um, yeah, it's when you create a dynamic where I really truly do believe it's the microbiome's function that is the key thing that is like um causal in healthy plants. But how do you get the microbiome to function well? It's different in every soil and every week in every country and every state and every county and every field. Um, you know, you'd have to be present with the moment and the land and stay present with it and support it as well as you can.
yeah, great. Um, if grains are raised regeneratively and fed to animals, could the meat be as nutrient dense as grass-fed?
That presumes a black and white, like they're eating grain or eating grass. Grass-fed varies very significantly. It's like you eaten poor quality hay for 3 months, slaughtered in March. Not looking too great. Eating a little bit of high quality grain in October while you're on a beautiful, fall pasture, probably looking pretty good. So there's continuums everywhere. That's the whole point. It's not black and white. Um, and this is why we have science, is so we can actually have a framework to measure and not have to ask some random guy called Dan, but actually be able to have an honest scientific framework to look at.
Yeah.
Yeah.
And were any of your samples for beef done with like baleage, silage?
Hmm.
I would assume that there would be differences there.
Absolutely.
Yeah. Yeah.
And
Good.
it looks like, baleage done well can compete directly with uh feedlot systems on weight gain and price of production and massively outcompete on nutritional levels. Um,
Yeah.
so we can do better on price and same on grade and cost with baleage done well.
Hmm.
Yeah.
Uh, and then Samantha's asking, basically, are you looking for large donations or small donors, or what? Do you have a strategy in that regard?
Everyone.
Yeah.
Um, yeah, $5 a month is great. If you can do $50 or $5,000, that's amazing. Um, uh, yeah,
Great. Good. And then the last question I have here really is whether freshness and storage of produce is critical compared to, yeah,
well, I mean, being picked ripe is way better than being picked not ripe. So if you have to pick something not ripe to get it to the store without it being gone bad, then that's probably going to be a negative impact. But um, most things when they're picked, even if they're picked ripe, are not anywhere close to what they could have been when they're picked ripe. So you pick something ripe that's 90, pick something ripe that's 30, you know, like it's way better with storage and time and everything else to get picked at 90 and then degrade from there than it is to get picked at 30 and degrade from there.
Good. And actually, I was clarified. The previous question wasn't asking about large versus small donations. It was asking about whether you take investments as opposed to donations.
Yeah, well, everything that we're doing is in the commons. So there's no possibility of any return on investment. We're not building meters. We're doing the science that people who build meters will have to calibrate their meters to. So we're doing the pre-competitive work of defining nutrient density. We hope to put out then into the commons a framework that's trusted that business can compete around. Um, so I like to say your return on investment is karma. Um, you've helped to create something that could potentially have massively positive impact on the planet.
Okay. And then I think this will be the last one. We'll also be looking at quantifying health benefits that correlate to the bionutrient scores. Perhaps especially those countries with national health care that might find this an incentive, you know.
That's part of the definition. That's part of what we did with beef was we did human health trials. And so, yeah, we wouldn't presume to say this is better, this is worse without having it connected to some human health
Right.
test. Yeah,
Great. Well, we're really looking forward to having you again at the conference. How many years has it been since you were at the conference? It's been a little bit.
maybe two or three.
Okay.
Um, and then I was in Australia last year. I wanted to come.
Right.
I almost was able to, but I had a literally was in Tasmania the next day
Right.
and I just couldn't make it work. But
I remember that now.
I'm
Okay.
really excited to come back this year. It's going to be a great time. Um,
Great.
yeah,
Yeah, really looking forward to it. The information again for the conference is in the chat there, conference.acresusa.com, and you can find more about Dan at bionutrientinstitute.org.
yep.
And with that, we will sign off. Thanks again, Dan.
Thanks, you, Paul. Yep.
Yep.
Bye.
Have a great one.